Anyone familiar with the concept of lean? L-E-A-N. So lean is one. I picked lean because when I was a consultant, I advised on lean. Lean is a managerial methodology for driving improvements through the supply chain and industrial processes of companies. And I wanted to look at lean and everyone understand why 3D printing could be so revolutionary in the context of an industrial language. So lean, its primary discussion is about value. And its value is perceived by the consumer, by the customer. It's about printing, it's about manufacturing what the customer wants, when the customer wants it. And there are 7 plus 1, and I'll explain that, parts of lean, which if you can eliminate waste, if you can eliminate the inefficiencies, you have an efficient industrial process. 7 of them are eliminating defects. Defects are very bad for businesses making product. Okay? Customers would agree with that. Overproduction is very, very bad from a cost efficiency for companies. Waiting. Did anyone know that probably the most inefficient thing in any business is waiting? How many people are idle at their work because they're waiting for someone to finish the task that came before them? It's the same in industry. You have whole production lines waiting to do things until something is sent to them, and that causes a huge inefficiency in the world. And 3D printing plays a very important role in eliminating that. I'll come back to talent in a minute because I want to focus on people. Transportation. How much of our industrial process is spent shipping product A or material A to place B, place C, place C, place D? Inventory. So much of our capital in this world is tied up in inventory. Gathering dust, being underutilized. Motion. You know, just in an office environment, the amount of activity spent circulating documents, passing things from one to the other, waiting for meetings to happen. These are processes which bring inefficiency and unnecessary production, unnecessary processing. These are 7 wastes of lean. And in the world of real manufacturing, companies strive to drive these down. So how does 3D printing play a role in that? Well, think about it. 3D printing allows you to produce on demand. It allows you to produce not in batches of tens of thousands or hundreds of thousands. It allows you to produce what you want when you need it, at the touch of a button. This is when 3D printing is done right, by the way, not always. All of this is with a major caveat that 3D printing has to be efficient. Localized production. That is going to be an increasing theme of the industrial world. Not one central hub somewhere in South America, Asia, Europe, but the ability to produce wherever the customer is. And 3D printing allows that, enables that, without having to set up factories, huge factories and supply chains everywhere. Less steps in the process. The more steps you have in the process, the more inefficient the process by definition. So the fewer steps you have, the more efficient you become. Just the amount of work required for the product, the ability to do less work and to get the product out quicker, I'll talk about people in a minute, is very important. The ability to carry less inventory. Many businesses fail, not because they're poor businesses, but because cash is king. They have too much of their capital tied up in inventory. And many businesses don't get to growth, they don't get to the initial funding, because what do they need the funding for? They need the funding for working capital, for inventory. Taking that out of the way, enabling businesses to go to a service bureau and print the first 3 batches of a product without having to do a deal for a major supply chain build-up is a very important feature that 3D printing can do to unlock innovative young companies. And flexibility to respond quickly. This is a prototype that a sneaker company used to look quickly and iterate its design. In the world of pre-3D printing, it would take weeks to design a 2D drawing, to send it to somewhere in the world, to manufacture one of, send it back, it's wrong, send it back, it's the wrong color, send it back. It would probably be 4 to 8 weeks before you had a product you can look at and think, this is the design we want. This is ours. And this is printed exactly, there's been no post-processing or coloring to this product. This is printed exactly as it was sent down the file. So the ability to be flexible and respond quickly, if customers don't like the product, iterate, is very important. And most importantly, The hidden waste is empowering talent. When talented people are engaged in inefficient processes, you're not getting the best from your people. So the ability to engage people in innovation and creativity, for your design department not to spend 8 weeks waiting for the product to appear, but to immediately design and print. The ability for your supply chain people to be engaged actively in innovative, efficient work is very important. Design freedom is something that 3D printing unlocks. Faster iteration. We all know that the world of business is speeding up at a huge pace. Probably too fast. You look at the introduction of new telephones, it's by the time you've bought a phone, you've configured the software for your phone, you're already on the old phone. I mean, that's the speed of iteration in the market. 3D printing enables that, and it allows people to spend time on value-added activities. The tools that workers use in the plants, those can be 3D printed. And in fact, it's better that they're in plastic than metal, because when you're dealing with employees who get stress-related strains and injuries, the lighter, the better. So, significant proportion can be in 3D printing. So McKinsey reckon that there's a potential market of 230 to 550 billion that 3D printing could generate economic impact in the next 10 years. Now, whether it's the bottom of the scale, whether it's the top of the scale, whether it's somewhere in the middle of the scale, who knows? It's dependent on thousands of variables. But it's not 2 million, and it's not 10 million. It's very significant. And in a survey by PwC, and this is like traditionally PwC, I can say that having been a partner, very complex slides. You can already see that the dark blue is 2016 and the light blue is 2014. I won't explain the slide too much, but you can see, for example, we are not implementing 3D technology has gone down very significantly. We are implementing 3D technology now, and today in production has gone up 6-7% in 2 years. So it's happening. It's not just a theoretical possibility in 10 years' time, it's happening. So what does it look like? Just a couple of examples, and then I'll come to a conclusion. Across 6 categories. The first, this is Aurora. It's a UAV. This UAV was almost exclusively 3D printed. Now, what's the advantage of 3D printing a UAV material? The main advantage is most of the inside is hollow, reducing the weight absolutely drastically. That weighs 14 kilos, 30 pounds, flies at 150 miles an hour, and was designed to exact specifications. It's very strong. But because you can print with hollow structure inside, you don't have to print just full material, you can get huge weight advantage. And that's a real UAV that's flying in the skies somewhere over the world now. So UAV technology is using 3D printing, not just in the prototyping. The prototyping for sure, but in the actual manufactured product. Second example, some people would say this is a boring example, but it's relevant anyway. This is a high volume tool. This is a jig. This is a support structure to enable someone to build plastic door seals. Used to be in metal, was then manufactured in thermoplastic using one of our printers. Now, the average person touches this, it saves, I think it is, don't quote me on it because I'm remembering the slide, it saves 4 seconds a cycle by using this tool. There are 250,000 cycles a year of picking up, putting down the piece of equipment. And there's a 4-second saving each time someone does it. Plus, there's a major health benefit because it's a thermoplastic, it's much lighter than a metal, which a worker would actually have to be lifting up. And again, it's a jig and a fixture. And my point is, does 3D printing have the answer for every technology? No. And anyone who says it does is dreaming of 10 years' time. It will happen, by the way. It will happen, but not now. But are there technologies that companies are using on the day-to-day manufacturing line that they run, which could benefit from using a different way of printing, production? Yes, absolutely. Anyone know the company Normal in New York? There's a store in New York where you take a picture of your ear, you send it online or through an app to Normal, and they print headphones for you. Anyone had trouble with headphones that haven't fitted your ear exactly? They print the headphone exactly to the measurements of your ear. And there's a quantifiable benefit to the I'm not so fussy myself, but my kids, when they hear about this, very exciting. It takes 2 days to make and send to the customer. It's just an example. Would you just invest in 3D printing purely because of earphones? Obviously not, but it's an example. Production is moving towards customization, to what the customer wants. Customers in many industries are not settling for second best. They want something that fits their needs. I'm going to, for time, just skip over a couple of examples. But there are many examples out there of tools which, one of the advantages is lower use of materials. When you're only printing what you need, you generate less waste. When you're printing lower weight materials, you generate less material. There's a big CO2 and environmental benefit to printing on demand that does not exist in traditional manufacturing. Because anything that's printed for inventory that's not used is by definition wasted to some extent. This is a picture of a Harrier jump jet. It's a very famous clip, and I don't have time to show it to you. The nose, the wing under the nose fell off or didn't deploy as this ship on an US aircraft carrier took off, and it landed with this material thing on the bottom. Now that was not 3D printed. What was 3D printed is it would have taken over a month to manufacture the tool necessary to repair the jet. They used a 3D printing mold to do it and support material, and they were able to fix the jet within 1 month. Again, it's a practical example where the US Department of Defense is using 3D printing to speed up the supply chain. There are many examples of companies who have container ships all around the world. If they need spare parts, can you imagine the complexity of the supply chain to get spare parts to a container ship somewhere in the Indian Ocean? You can 3D print it in many cases. And Airbus already, this is an old material now, Airbus already is using in interiors, not flight critical equipment, I should point that out, but in aircraft interiors, the ducting, the stuff like that that's on jets, it's using 3D printed material from FDM, fused deposit material, in its production, not in prototyping, because it saves a huge amount of weight and it can be printed, custom manufactured. The complexities in manufacturing a part that has lots of different shapes in it is quite complex, and if you're only making a few of them, 3D printing is a much, much better option. I think the point is, it's very easy for me to focus on the very, can I use this word, the very exciting, sexy parts of 3D printing that you may be familiar with. The reality is in core manufacturing, in the way core product is made, there are huge advantages with 3D printing. And it's shrinking tooling costs, and it may not sound very exciting, but this is part of Industry 4.0. This is part of transforming the way products are made. So how does Europe benefit? And I made this point before. So two things. I spoke about it in the first meeting. The first point is we've got to get people excited about design and manufacturing. If you ask kids, do you want to work on a factory floor line? Most kids say, probably not. Do you want to be involved in the way products are made? Do you want to be involved in the way things are designed and built? Absolutely. We've got to make the generation of the future interested and excited in technology. 3D printing is an amazing tool. As I said before, if you're involved in making and touching and feeling products, you're much more likely to be inspired by it. So the first thing Europe can do, and Europe has some very high quality educational delivery systems, is to engage youth in the exciting areas of STEM, science, technology, engineering, and mathematics. And 3D printing plays a role in it. Secondly, 3D printing is a strategy. Okay? A large aerospace company tomorrow morning is not just going to decide to implement 3D printing. It needs a full supply chain strategy on where the benefit of 3D printing is versus traditional manufacturing, based on its goals, based on the degree to which it wants to be customized. We need to start opening eyes up to that. The last 2 points is it's not all theory. In prototyping, in some of the tools I showed you, in some of the jigs and fixtures, businesses can already start enjoying the benefits. And where they have an issue with the capital expenditure required for machines, there are service bureaus printing. Now, one of the jobs I did in the last year is we acquired 2 service bureaus in the United States who are involved in traditional, conventional and additive manufacturing, metal printing, plastic printing, all the technology types. And I've been leading the integration of those companies into Stratasys. You can start now with service bureaus. You can buy hardware. There are whole delivery mechanisms to enable businesses to use it now, not just in the future. The last point is it needs to be done holistically. Additive manufacturing, 3D printing is going to be disruptive. Those companies that adopt it are going to succeed and have the ability to innovate faster and create quicker than other companies.